In today's webinar, I want to introduce you to AnalyzerPro XD and show you how our vendor-independent software package can help reduce the bottleneck in your mass spec data processing workflow. AnalyzerPro XD is a mass spec data processing tool. With its ability to process both low and high resolution MS data from GCMS, LCMS, DART and MALDI, it is ideally suited to reduce training overheads and simplify your workflow. Regardless of the type of MS data, AnalyzerPro makes a comparison of multiple samples possible. Our approach provides statistical results that allow you to seamlessly connect back to your raw data. We will first look at how AnalyzerPro XD can be used to visualize and process DART MS data. We will then look at how to process GC and LCMS data using our proprietary algorithms to detect obscure components that existing software packages are unable to find without additional information. I will then show you how we have extended this process to GCxGC-MS data. And as we process each of these three different types of MS datasets, we will also show you how you can benefit from the statistical tools in AnalyzerPro XD. Let's get started by looking at some DART data that was acquired on a thermal Q exactive orbiter. DART and DirectMS data samples are usually acquired into a single data file. In this example, a DART QuickStrip 96 card was used. The card consists of 8 rows and 12 columns. When acquired, the data is grouped into 8 sections, with 12 samples within each section, as can be seen here. The QuickStrip card was spotted with 48 replicates of 2 common cold medicines, Dayquil and acetaminophen. Using the simple parameters, we are able to automatically identify samples in the data files as shown by these light blue sample markers. If necessary, we can also add or remove samples manually. Finally, we can simply click the Split Data File button to split the single data file into 96 separate data files, each new data file corresponding to each of the samples on the QuickStrip sample card. We can now set the data processing method. We can create an average component spectrum for each of the data files, or in this example, we can use features. This is where each and every mass value is treated as a single component. AnalyzerPro XD automatically creates a sequence from the new 96 data files. Before we process the sequence, where information about the samples is known, we can add it to the category column. After processing, we could then apply statistical analysis to these components or features that have been detected. Principal component analysis is useful when we are working with large datasets and are interested in uncovering relationships or clusters within the dataset. Here we can see that the majority of the Dayquil and acetaminophen samples fall into 2 clusters. However, there are a few outliers in each category. The loadings plot shows how strongly each mass feature influences a principal component, i.e. a sample, in the score plot. We can then click on the components in the loadings plot to directly visualize either the component spectrum or, in this case, the mass feature. The Volcano plot allows us to quickly visualize the mass features that are statistically significant when comparing 2 categories of samples. Our blue triangles are common features. The green triangles represent those features unique in the acetaminophen samples, and the red triangles are unique to the Dayquil samples. We are also able to display a heat map of the sample matrix. The intensity of the different masses and the colours of the display can be customised to show a gradient of colours, or in some cases, yes-no results, depending on the threshold parameters that have been set. In this case, we can clearly see that there is a higher intensity of mass 303.1 in the first half of the sample card compared to the second half, and this coincides with the differences between the 2 medications. We can also process DirectMS data quantitatively to report calculated amounts for unknown samples. In this example, we show the calibration curve and results for codeine. Here we spotted 3 replicas of 8 calibration levels and use deuterated codeine as an internal standard when calculating our response ratio. Following a very similar workflow, AnalyzerPro XD can also be used to process LC or GCMS data. Before I present an example dataset, I want to introduce the concept of chromatographic deconvolution, as this is a key feature in our data processing. With resolved and even partially resolved peaks, we can easily see that there are two components. However, when we get to unresolved peaks, it may be very difficult for a user to realize that there are still two components under the peak. The chromatographic deconvolution allows the user to identify multiple components with no prior knowledge of the samples. Here we can see that the software is able to detect two components under a single peak. Each component will have its own unique mass spectrum and retention time. We will now look at an example of GCMS data processing with a number of coffee samples from around the world. 4 coffee bean samples from different geographical areas were analysed 5 times. The replicate analysis of these samples helped with the ultimate statistical evaluation of the data. The objective of this experiment was to determine if we could automatically measure the differences between coffee samples from different geographical locations using high-resolution headspace GCMS. Sample preparation was quite simple. An amount of each coffee bean type was added to a headspace file. Boiling water was added, and then after cooling, an internal standard was spiked into the sample. A portion of the final solution was then sealed in another headspace vial and used for analysis. The analysis conditions are shown here. The key points are that it was a headspace analysis on GC time of flight mass spectrometry running in EI mode using a 30-meter wax LC column. Typical total line chromatograms for each of the 4 coffee beans are shown. Although there are some visual differences between each of the chromatograms, those differences are particularly subtle. In fact, when you overlay the chromatograms, you would probably see that there are more similarities than differences. I am sure you can see some subjective differences between each of the chromatograms, but it is very difficult to try and objectively describe these differences. Different users might describe the subtle differences between the chromatograms in different ways. Clearly, a consistent and objective approach is required. To do this in AnalyzerPro XD, we need to process the data, and here is an example of a processed data file. We can view and interact with the chromatographic data and the raw spectrum, as well as review the detected components. To objectively look at our coffee bean samples, we can create a sequence, specify the category information, and then click on the Process Sequence button. After we process the sequence, the software is able to automatically generate a data matrix. This matrix shows each component found in each sample and the relative or absolute intensity or area of each. This can be quite a daunting dataset, but with the use of statistical analysis, we can visualize the differences between each of the categories of samples. PCA is a statistical data reduction tool which allows us to visualize our data matrix. Here we can see in both the 2-dimensional and the 3-dimensional PCA score plots that there are 4 different groups of samples in our sequence. We can also see that the differences between the Brazilian and Guatemalan beans is less significant than the differences between the other 2. Nevertheless, there is a difference between the Brazilian and Guatemalan beans, and we can use the Volcano plot to help identify those differences. Again, we can see our common components, the blue triangles, and the components that are unique to the Brazilian coffee bean and those unique to the Guatemalan coffee bean. Take, for example, pyrrole. When present, the retention time of the component was stable over the dataset. Over the 5 Brazilian samples, from the bar graph, we can see that pyrrole was found at a relatively consistent level. In the Guatemalan samples, we can see that pyrrole was not detected. This is indicated by the red crosses in the RT display and the lack of data in the bar graph. Using the combination of PCA and the Volcano plot, AnalyzerPro XD allows us to quickly compare how components behave over the entire sequence in an objective manner. We can look at how GCxGC-MS or two-dimensional LC-MS can be processed in AnalyzerPro XD. In this example, Scottish and American whiskies were analysed to see if it is possible to objectively differentiate the different whisky brands. 10 different whisky samples were acquired using time-of-flight GCxGC-MS. 3 different sample preparation methods using solid-phase microextraction fibres were used to assess which method was most able to differentiate the whiskies. Samples were run in triplicate. The key point is that the data was acquired on a fast-acquiring time-of-flight mass spectrometer, which is important to achieve an adequate number of samples across the very narrow chromatographic peaks. The primary column was non-polar and the secondary column was polar, which is typical in 2D GC. Typical 2D contour plots and the relevant reconstructed one-dimensional total line chromatograms are shown for each of the sample preparation methods. The contour plots show more separated peaks than you see in the one-dimensional reconstructed plot. This shows the power of two-dimensional chromatography. In 2D chromatography, there are usually a single detector, such as an MS, at the end of the second column. The second column separates many modulations or time slices from the first column. From these modulations, it is then possible to reconstruct a one-dimensional chromatogram. Using AnalyzerPro XD's 2D analysis results viewer, we can see what is happening in the second dimension of chromatography. Here we can see an example of where 2 components are not resolved in the first dimension, but are clearly resolved in the second dimension. Here we can see how our 2 components elute over multiple modulated time slices. However, it is not always the case that components are chromatographically resolved. So even with two-dimensional chromatography, you may still need chromatographic deconvolution. In this example, we can see that there are 2 components that closely coalute in the second dimension. Chromatographic deconvolution will allow us to separate these components and get unique mass information for each. To objectively look at our whisky samples, we can easily create a sequence, specify the category information, and then click on the Process button. Looking at the PCA score plots for the 3 different sample preparation methods, the neat whisky showed the least amount of overlap between the different whisky brands. Again, we can return to the Volcano plot to compare 2 of the sample categories and interact with the data. Here, we show how the user can library search that component spectrum. This was a brief introduction to AnalyzerPro XD, but hopefully you will have seen how easy it is to process various types of MS data. We have shown how AnalyzerPro XD can be used to objectively determine measurable differences within datasets and how it can increase your productivity by reducing the number of software packages used within your lab. AnalyzerPro XD can reduce the processing bottleneck as there isn't a need to export results to multiple packages for data reduction and statistical analysis. This improves your workflow because you can directly relate your statistical results back to your raw data or your process results.